purpose of this experiment is to find out if adding a large cone to the wide part of a Venturi here, this end, makes any difference to its performance. So the first lot of tests will be just from here to there, and then I'm going to add this on. For today's tests, I've purchased this laser rev counter, and it works by hitting this reflective strip with a laser and bouncing back. And I've also purchased this anemometer. If I blow through it, I can get 22 miles an hour wind. Very cheap, only £10 each. Okay, the blower is set up at 7 feet distance. I reckon this should be over 550, maybe 600. So what we got? I hope you can see that properly. 700 RPM. Still going up. 760. This is a really nice little gadget for £10. If you want to get one, it's on Amazon. Sunshi is the name. I'm just testing it now. 780, 789. Okay, I'll call this one 780 because it stopped going up. I'll call it 775. Okay, the blower is now 6 feet away. Have to give it a little push. When I make the final turbine, it's going to need more than 4 blades, because with this one you can find dead spots, and if it stops in a dead position, the wind won't start it. This one may go over 1000 RPM. I've written down all the wind speed changes in an earlier test, and I'll show you the results in an Excel sheet at the end. So it's settling at about 960 here. Still going up. Let's call that 970. This time the blower is 5 foot away. Well, last time we got 970. This time it's looking like 1200. It's very close to 1200. There we go. So let's call this one 1200. I've moved it to 4 foot, left it running. Maybe we'll get 1500 or more. 1380. I'll move the laser to the edge. Yeah, it stops picking it up, you see. If I put it back there, it'll pick it up again. If I put it on there where there's some shiny things, we get nonsensical readings because there's little shiny screws there. There's 2 of them, and this is blue gloss paint. So this is very important to make sure you've got the right thing. So here this is just plywood, and it's picking up the strip correctly. I wouldn't have known that unless I'd read all the reviews on Amazon, what people had said. I'd be getting nonsense readings. So let's call this one 1375 RPM. In this test, the the blower is at its closest, which is 3 feet away. Switch on my rev counter and press that button. So we've got a laser. In a moment I'm going to test making the large end of the Venturi much bigger. And I'm expecting to see an increase in speed, especially under low winds. So this looks to be 1700, 1690. Keeps changing, which is somewhat confusing. So close to 1700, and yet it keeps going back. There we go. Let's call that 1700. For the next test, I've made this entrance to the Venturi so it's much bigger. It was previously 10.5 inches at the big end, and now we have roughly 2 foot. 2 foot wide, and you can see it's beautifully made from duct tape and plastic. Okay, now we're 11 feet away with the big Venturi. Let's give it a little start, see if it needs one. It's trying. I was hoping it would increase a bit more than this. So 11 foot away last time gave us 155. That's with the small Venturi. It's actually picking up speed, which is really pleasing. But I must admit I'm a bit disappointed at the moment. Unless it goes over 155, my theory is busted. We shall see. 161. Okay, theory. So it's taken a long time to get going, but you can see here we've gone over 200, 220. So it seems I'm a genius after all. We're getting up to 300 here. Taking a long time. There we go, 300. So that's double from 11 feet away, putting this great big funnel on the end. More than double. And we're still going up to 360, 370, 380. One has got to ask oneself at this moment, what's the reason that it's taking so long to get up to speed? It's 400 there. It's going to hit 400. Look at that. How amazing. Seems to be, I'll settle for 410 there, even though it's going above it. It's actually no, 420. It still seems to be increasing. You're going to give us 430? It did there, 430. This is very strange. There's something strange going on with the physics here. Anyone who knows what it is can leave a comment. So we'll call this one 430. We'll stop this. I've left it running and I've moved it to position 10 feet away. As we're learning, it takes a while to get going. So we had 400 last time, or some, what was it, 430 last time. And that was 11 foot. Now with a small Venturi at this speed, we had 400 at the 10 foot distance. And I can see we've got an improvement there. But not as much as the other one. Whoa, this thing's giving me funny readings here. Okay, I trust this reading. 480. Doesn't seem to be increasing. Call this 485. Okay, now at position 9, with the big Venturi, and there's the blower. You can see it's all the way over there. I'm not kidding, this really is good. The speed seems to give vibration. So we've got 500 now. Let's just check. At 9 foot last time we had 500. So that's not going up. So as I suspected, it's the low winds that get the biggest boost from putting a great big mouth on this Venturi. The medium winds, it's not such a dramatic effect, but we've got roughly 1% uplift. Actually no, we haven't. We can say, yeah, 1%. I'm going to mark this at 505. Now position 8. Last time we had 530 RPM. Surprisingly crappy. It looks to be even slower. Fletcher, you're in the wrong place. Go outside. Out. Out. Get your ball. Get your ball. My dog is so curious. So 520. Position 7 with the big Venturi. Last time was 775. I'm surprised this isn't higher. There's just so much of a funnel for it to get the air. Hello, it's going up. Going down. I'll have to call this one 775 as well. Okay, 6 foot away. Last time with a small Venturi gave us 970. So we can guess this is going to be 970 again. Very close. Not getting a lot of difference. Seems to be a tiny little bit less. 980. 980. We'll call this 980. Okay, position 5, which as you know is 5 feet away, with the big Venturi, and last time we had 1200. You can see that. Now we're up a bit here. So we have, I think, a strange kurtosis, which you can get with testing trading systems, as opposed to a bell curve. It's to do with the distribution of the results. So this is 1250, which is better than with a small Venturi. Okay, this is position 4, 4 feet away. Last time 1375. Making a lot of noise. Seems faster. So that is a kurtosis. So with this great big cone, even when it's right inside it, that's 1550, which is quite a big improvement from 1475. So it's not like you would expect it to be, is it? Okay, so I've made the Excel sheet with a little chart, and the point of it is to answer the question: does having a large entrance to a Venturi improve the overall performance of a wind turbine? And looking at this, you have to say yes. This is what I was talking about earlier about the kurtosis, because at this distance there was a huge difference between 155 with a small Venturi and 430 with the large one, which is what you can see here. And at the other end, 1375 with the small one, 1530 with the big one, 11.27%. In the middle, these areas here, very little difference. You know, you can't really measure it because the rev counter was moving around and changing a lot, but these are all pretty much the same, these results, as from large to small. The shape of the Venturi, which you're going to see in the next clip, is by no way optimal, because I just made it out of anything I could find for the time being. And it's very interesting. So you can see that the black line is with the large Venturi, and the orange line is the small Venturi, and there's a higher speed achieved at the low speed and the high speed, and in the medium speed there's no difference. Now, what's strange is this odd curve with this kick in it at 8 foot, which occurred in both the tests. So I'm guessing this is some kind of internal turbulence in the Venturi as it is, and I think if I made a better one, the line would be a more orderly curve. This Excel sheet shows the actual wind speeds rather than the turbine speeds. So holding the anemometer right at the blower, zero distance, we got 36 miles an hour, and when it gets to the point where it matters, 14 miles an hour. So this is the wind speed without a Venturi, which is this green plot. So the question I've been posing to myself, the reason I'm doing these experiments, is to find out just how much increase you get by using a Venturi. So the large Venturi fared better, as you saw from the previous experiment, and this is the increase percentage. So the highest one was here with a 12 mile an hour wind speed. It became a 21 mile an hour wind speed, which was 75% increase. And they're all increased, but none of them are 400%. You may notice, and Invelox claimed their Venturi increases wind speed by up to 400%. So I'm not sure if that's strictly true now, looking at this, even though my Venturi is probably the crappiest one ever made. How critical the shape and length and angles is, I can't see it making that much difference. I mean, 400%, to get that, I don't think I could get that, even if I spent a few years testing 1,000 types. But that's just my opinion, it's not fact. So thanks for watching. If anyone's got any ideas about Venturi shapes and angles, I'll be most interested to hear from you in a comment. Thank you for watching.